Let's continue with exception handling. So in this video, I will be talking about exception handling in Java programming. So this is normally occurs during runtime. We call it as runtime error as well. You compile it successfully, but when you run your program and then somehow your program may be being terminated by the system automatically, and you have to find the error. So the problem is that when you compile it, it's successful, but when you run it, you are having a problem. So I just want to give you an example here. The 4 scenarios that probably might occur during when you run your program. Yeah. So the first one is user key in invalid data. So maybe you want the user to key in integers, but when they key in other than integers, then probably your program will also giving an error for that. Yeah. And when you try to open file, let's say your program is trying to open a file, but the file is not there, and then it will give you an error as well. So network connection, if your program required a network connection, but if there is no connection, and then it will give an error. JVM, virtual machine run of memories, for instance. So these normally occurs when you run your program. It is easier to detect errors if it is detected during the compilations, so you can just fix the code. But in this case, you have to do some kind of testing. So to avoid this to be happening accidentally, that's the reason why we must consider this exception handling. Yeah. If you look at here, it is actually handled by throwable under 2 subclasses, error and also exceptions. So I'm not going to touch on this error. We're going to touch on this exception that in fact can be divided into 2: check exceptions and also runtime exceptions. So those who can be detected during the compilations, you can easily fix it, but somehow when you run the program and then the error occur coincidentally or without you even think before, so it might cause problems to your program. So in order to improve your coding, so it is better for you to use this exception handling for any potential of errors like this one, so that your program can handle that, and then the program can still be continued and run. Yeah. So so in this video, I'm going to show you how to use these 5 main keywords in exception handling. The first one is try, catch. This one should normally will come together. Try and catch, and then throws, and finally. Yeah. So in order to give you a brief ideas about what is this and how you're going to use this, so I'm going to use G-graphs to give you an example. Let's have a look at the first one. I will go for try and catch first. So imagine that you have this class, yeah, exception, and then you have mainstream. Okay, for instance, the first potential error is, division by 0. All right, before I go to that, I think I want to explain to you this. This is an example. Your runtime exceptions. It could be arithmetic exception. This is if the potential error is very much related to arithmetic operations, division, especially. You cannot divide by 0, for instance. And then null pointer exceptions. For instance, if you have an array and you point to the data which is exceeded the numbers of the data. Say if you have 10 elements of data, and then if you are pointing to the last or to the 11th array of data and there's no data there, and then that will probably will give you the error as well. So that one is a null pointer error, and also other unchecked explanations or any other runtime exceptions. Yeah, those are just an example. So in this case, I would just want to give you the example of arithmetic exceptions. For instance, division by 0. So imagine that you have this integer x is equal to let's say 10 divided by 0. This should be giving you the error. So let's say we want to print out system let's say print 1. I just want to show you whether we can print this or it will go out from the instructions. All right, so in this case, if you compile this, all right, let me all right, when you compile this, you couldn't find the error, so it seems to be that you cannot detect the error here. Yeah, but when you run this program, right, it will give you this exception. So this is another example of exception handling. But in this case, what happened is that when you divide by 0, at this level of instructions will give you this error. Now, if you can observe here, it will not print, it will not do these instructions, so there is no print 1 here. All right, so in this case, the system will read line by line, and then up to this instruction, and it will straight get out from the overall program. So to avoid this, in fact, we also want to handle this potential error. If this is the potential error here, so anything, this is just an example. Yeah, so you should use try. We want to try this. Yeah, we want to try that one is for yeah, this is for the class. Yeah, this is for this main. Just want to mark that so that you don't. This is for the try, and then so you try this for any potential error, and then you try to catch that. you know, if there's an error, then catch. So this one is exception, arithmetic exceptions, and you can use that arithmetic exception. Yeah. Arithmetic exception, and then any variable. So let's say exception, arithmetic exception, and curly bracket, and then let's say if this is true, meaning to say that you catch the problem of arithmetic expression, then you try to catch what is it, and then we try to print it out. Yeah. System, I'll just copy this to make it faster, and let's say we print that AE. Yeah, whatever, you know, you catch that problem and then you print it out. Try to, okay, no error. Right, when I try to run this program, right? Okay. So now this is the first program. Just now will only display this, so it will differently giving this output, yeah, saying that exception in thread in this program and the main, and divide by 0, and we capture this, you know, we capture this under here because it is arithmetic exception, and then we display that, yeah, we display the error here. So meaning to say that this catch true and it will do this, yeah, but if you can see, it will skip this print one because the problem is here, and then alright, arithmetic exception managed to catch that problem. I will jump to here. So if I, let's say, put this one as print 2, yeah, this is under catch, yeah, catch. So this is the error, and when I try to compile that, all right, clear, no problem, and then when I try to run the program, all right, if you look at here, I can print this print 2. So meaning to say that the program will detect the error, but you know, they still continue the program reading the instructions by looking at this cage, because this cage managed to catch the error and print out what the error, sorry, okay, oops, this one, yeah, AE, and then after that it will continue with this instruction. All right, so meaning to say that the program still can be continued, yeah, and in fact, if I put this outside of this cage, I run that, oh, sorry, I put that as print 3, clear first, okay, no error after I compile, right, and it will print 2 and print 3. So how are you going to customize this input, for instance? Yeah? If you can display or you can catch the error, you probably can just say, I want to remove this one first, yeah, maybe you can say division by 0 is detected. Okay, yeah, so I compile that, no error. When I run this, right, and when I run this program, so we can give customized error to the user. For instance, this one, division by 0 is detected. Yeah, so you are detecting this, and then you customize the output. All right. This catch, you should put the right exceptions to here, right? If it is arithmetic, then you have to go for arithmetic exceptions, because otherwise, if you use a different exceptions, like what is the other one? Null pointer exceptions, yeah. Null pointer exceptions. Null pointer exceptions. Let me check that. Complete. Okay, no error. But if you run this, it will not print this. Yeah. This is the previous one. I clear that one first. So if I run that, all right. So if you look at the output, yeah, it will not print this, because this exception is not null pointer exceptions, right? So these null pointer exceptions can only detect if something wrong with your array. So if you are trying to look into all potential of error for the array here, and then you can use this. So you can have a look at these exceptions. There are quite numbers there, and you have to choose the right exception under this catch. Otherwise, it will not catch the error. Yeah. You can, in fact, also have more than one catch. If this try, you have quite numbers of potential errors to catch, you probably can have more than one. For instance, you can have this null pointer exceptions if in case you have an array or here, and at the same time you probably want to look into all the potential of arithmetic exception errors here. So you can have this cage, and this is another cage, and then you can have any other cage or any other exceptions. You can put a few cage here for different exceptions. Yeah. So I just want to give you an example here. So we have two here, but I want to put this one as arithmetic exception. I compile that. Yeah. I run this program. All right. So this will call this arithmetic exception error. Yeah, this one, because these fall under arithmetic exception. All right, and the next one is actually how to use throw. You can manually throw the exception without having even the error, and then you can do it manually. Just want to give you an example here. So let's say in this case, divide by 1 is not in fact an error. Yeah, but if I compile that, if I run that program, all right, it will print 1, right? So but I want to say that in my program that if you divide by 1 and that should be an arithmetic error. So you can have if x is equal to 10, yeah, so you can say true arithmetic exceptions. You can call that, yeah, ITHC, you call that arithmetic exceptions. So what does it mean? So if x divided by 1, or if x is the same value, we are division by 1, we want to force that, look, this is an arithmetic exception error. And here maybe you can say do not divide by 1. Just an example, yeah. Okay, I run that, compile that. Let me check. This is right. New. So this is how you write true. You have to throw that new arithmetic exception. It should jump to this, catch, and display this. Yeah. Okay, complete. I clear that one first. If I run this program, do not divide by 1. So because we are forcing the exception handling to execute this, yeah, because this is our definition of arithmetic exception. All right, so that is how to use throw, where we actually manually call the exception handling. So you should write as true, throw, new, and what the type of exception handling that you want to call. All right. Next, we are going to look into the keyword finally. Finally is if you have a lot of cache here, but you want to make sure that as a default, so finally that's going to be the last thing. Is it will always be go to the final things to do. So you can use the word finally. So that's going to be the last thing. It is compulsory for the system to execute that instructions. So under the program code, it will check whether or not that the exception occurred, either yes or no. If it is yes, and then it will look into the exception handled, yeah. So it will go to any respective exception handling, if it is arithmetic or null pointer and so on. But if it is not in any of this category, and then the default is the finally. So final is the last. Finally is the last system or exception handling that will always be executed, right? So you can use the word finally, yeah, and then you can have this whatever that you want to do under this body, yeah. As for instance, system, I just want to display this finally will always be executed, yeah. So whether it is this one, or it will always execute that finally. Let's have a look at that clear first, and right. All right. Let's. All right. Sorry. Okay. I'll clear the screen. If I run this, you see, even though that it will call this arithmetic exception, but this finally will always be executed like this one. All right. So in any case that you you need to handle the problem, and you want to make sure that everything will be covered, then you can use that finally, right?